Hello everyone, welcome back to Edumoon tutorials. In this particular lecture, we will be covering binary codes. Well, for this one also, we will be making two parts like part A and part B. In part A, we will discuss BCD, BCD Addition and BCD Subtraction. Myself Sohana of Andhra University, and let's get started. Now, we have many number of binary codes. Well, strictly sticking to the syllabus, we will be covering only BCD, Gray code, XS3 and 8421, 2421, 84 minus 2 and minus 1. Coming to BCD, we will be covering addition and subtraction, how to do BCD addition and BCD subtraction. In this particular video, we will be covering only this topic. In the next part B video, we will be covering all these three topics. Okay, now let's get into BCD. Now, why do we actually need BCD? Well, for example, if you consider the number 14 in the decimal format, in its binary form, we represent it like 1, 1, 1 and 0. Well, for coming into the BCD part, how do we do that? We consider each and every digit separately. Like for 1, we have a binary code using 4 digits as 0, 0, 0 and 1. And for 4, we have a binary code like 0, 1 and 00. So your BCD number will be 0001 and 0100. So this part gives you the value of 1 and this part gives you the value of 4. So in order to represent 1, 4, we will be considering it as separate two individual digits and then form the BCD. Now BCD uses only digits from 0 to 9 and hence it uses only 4 binary numbers, binary digits to represent them. Now regularly we just know how to convert the decimals into the given binary formats. We will be using only 4 bits for this one. So for decimal 0, the BCD conversion will be 0000, and for 1 it is 000 and 1, and so on till 9, which is 100 and 1. Always remember BCD only uses 0 to 9 decimals. Okay, now let's get into few examples on how to do BCD addition and BCD subtraction. Consider first example to be 8 plus 4. Now how do we do it? First, the given digits should be converted into its binary forms. So 8 is represented using 1, 0, 0 and 0. Always just use this numbers 8421 so that it will be easier for you to solve the problems. Now 4 is represented using 0, 1 and 00. Now we do the normal binary addition. You already know the rules. So 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 is 1 and 1 plus 0 is 1. Now by seeing this, we can easily say it is a 12. But BCD cannot use any value greater than 9. That's what I have written here. If result is greater than 9, we say that it's an invalid BCD. So for the correction, we add 6 to the value. So always remember that whenever the value you get is greater than 9, always you be adding 6 to it. So now 6, we'll just add 6 to this one. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 0 with the carry 1. 1 plus 1 is again a 0 with the carry 1. Now this one will be your final answer. Now 1, 0, 0 and 1, 0. Now how do we convert this value? Always consider 4 bits in case of BCD. So this 4 bits comes under one pair. And then again you can step in zeros to it, and now these 4 bits come under the other set. So this value is 1 and this value is 2. Hence your answer is 12. Okay, now let's get into the other example. 8 plus 9. Again, first convert the given digits into its binary numbers, which is 1, 0, 0 and 0. And for 9, it is 1, 0 and 0 and 1. Now, try adding these two. 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 0 is 0. 1 plus 1 is a 0 with a carry 1. Now, just don't discard the carry here. Always remember that whenever you solve such kind of problems, never discard the carry at the very first step. What you will be doing is here is that we need to check if the value is greater than 9 or not. Absolutely the value is greater than 9, right? So now we'll try adding 6 to this one. So 0, 1, 1 and 0. We'll just add these two. So it will be 1, 1, 1, 0 and a 1. Now this 1, 0, 1, 1, 1. Now we need to separate them in the set of 4 bits. So this 4 bits comes under one set and this one will come like you can here also happen 3 zeros. Its value is not going to get changed. So this value is 1 and this value is 7. So your answer is 70. Hence you got your answer. Okay, now let's try a bigger example. Consider the digits 1, 8, 4 plus 5, 7 and 6. Okay, for 1, 8, 4 and for 5, 7, 6. So 1 stands for 0, 0, 0 and 1. Always write this 8421 so that you will be getting to know what values are, what exactly ones and zeros are to be placed. So now 8 is 1, 0, 0 and 0. 4 is like 0, 1, 0 and 0. Now 5 is 0, 1, 0, 1. And now 7 is 0, 1, 1, 1. And 6 is 0, 1, 1, 0. Now try adding them. 0 plus 0 is a 0. 0 plus 1 is a 1. 1 plus 1 is a 0 with a carry 1. And this is a 1. Okay, 1, 1, 1 and 1. 1 plus 1 is a 0 with a carry 1. And here it's 1, here it's 1, here it's 0. Now, we need to find whether these values are greater than 9 or not. This set is greater than 9. Now, this set is also greater than 9. This set is only lesser than 9. So, this one is okay. These two are not at all considerable for a BCD. So, now we will add 6 to these two numbers only. Okay, 0 plus 0 is a 0. 1 plus 1 is a 0 with the carry 1. 0 plus 1 is again a 0 with the carry 1 is a 0 with the carry 1. Okay, 1 plus 1. Now, okay, for whenever you get a carries like this one, do not add it immediately. I'll tell you why. First, just go on with the addition. 1 plus 0 is a 1. 1 plus 1 is a 0 with the carry 1. 1 plus 1 plus 1 is a 1 with the carry 1. Plus 0 is a 1 plus 1 is a 0 with the carry 1 again. Now, this number is as it is, like 0. Okay. Now, whenever you get a carry like this one, we need to add that carry to the next pair. Okay. Now, this one will be coming to this side. And this one will go to this side. Okay. Now, your answer is 0, 1, 1, 1. And 0, wait, 1 plus 1 is 0 with the carry 1, 1 and 1. And here the 0, 0, 0 remains as the same. Now, 0, 1, 1, 1 equals to 7. And 0, 1, 1, 0 stands for 6. 0, 0, 0, 0 stands for 0. And hence your answer is 760. I hope you're very clear with this one. I'll just give you a gist of it again. First, you'll be doing the normal BCD addition and check each set of 4 bits whether they are greater than 9 or not. If it is not greater than 9, then it's a correct one. If it is greater than 9, it's an invalid form and you will be adding 6 to it. Now, after adding, whenever you get a carry, do not add the carry immediately. First find all the normal binary additions and then the last step, carry that one to the next set of bits and then add and then you'll be getting a final answer. Okay, now we are done with the BCD addition. We will go into the BCD subtraction. Well, for BCD subtraction, we can use either the 9's complement or the 10's complement. At first, we will be seeing how to do using the 9's complement. Okay, now let's get into the rules. Rules are so similar to that of the normal 9's complement subtraction which we already discussed in the previous video. Well, only a little part of it gets changed. So let's get into the rules. Okay, now first take 9's complement for subtrahend. Add it to the menu and using BCD addition. Now again check if the result is a valid BCD or an invalid BCD. If it's an invalid BCD, you will be adding 6 to it. And then later, we will be shifting the carry to the next bits. And one more point to be considered here. If end around carry is generated, add it to the result. If it's not generated, say the value is negative and again find 9's complement to get the actual result. Okay, you will be getting to know properly if I start solving the examples. Okay, now consider the first example to be subtract 81.2 from 98.3. That means 98.3 minus 81.2. Okay, at first what we will be doing, this is your minuend, right? And this is your subtrahend. I hope you guys are clear with this point. Now, we need to find the 9's complement for the subtrahend. Okay, 81.2. I already told you how to find the 9's complement for this one, right? Just subtract each and every digit from 9. So, 9999. Your answer is 7.81. Right. Now, this one should be added to 98.3, right? Okay. Now, for 18.7, consider each and every BCD equivalent. So 18.7 is 0, 0, 0 and 1. Just write 8421. Okay, and 8 stands for 1000 dot 7 stands for 0, 1, 1 and 1. Now 98.3, 1001 and 8 is 1000 dot 0, 0, 1 and 1. Okay, now find the normal BCD addition. 1 plus 1 is 0 with the carry 1. 1 plus 1 plus 1 is a 1 with the carry 1. 1 plus 1 is a 0 with the carry 1 and 1. Okay, dot 0, 0, 0, 0 with the carry 1. Now it is 1 plus 1 is 0 with the carry 1, 1, 0 and 1. Okay, now consider all these bits, okay? So this is 1010, which is not a valid BCD. And now, do not leave the carry here. Considering the carry which is 1, 0, 0, 0 and 0, this is not a valid BCD, okay? So again, this is not a valid BCD. And 1, 0, 1, 0, which is also 10, is not a valid BCD. Now, what we will be doing? We will be adding 6 to all of them. 0, 1, 1 and 0, 0, 1, 1 and 0. Okay, now again find the BCD addition. 0, 1 plus 1 is a 0 with the carry 1. So 1 plus 1 is 0 with the carry 1. It's a 0 with the carry 1 again. Just leave that carry as it is. We will discuss it later. Now for these 1, 0 and 1 and a 1. And this is a 0. And then the carry just gets dropped as it is. Again 0, 0 with the carry 1. 0 with the carry 1. 0 with the carry 1. Okay. Now we got carries for all the 3 sets of bits. Now what we will be doing according to the rules? We will be shifting the carry to the next bits. Okay. So this one gets placed here. This one gets placed here. Now, according to the rules again, check this one. If end around carry is generated. Now see, we got here an end around carry, right? So this one will be adding it to the result finally for this one. Okay. So now this becomes 0, 0, 0, 1, 1, 1, 1 and 0. 1, 0, 0 and 0. So what will be your final answer? It is 17.1. So this is your final answer. I hope you guys are very clear. Just go through the rules perfectly and you can solve any other problem. Now let's take another example. We will be considering the example like subtract 336.25 minus 623.85. Okay, now how do we do this? This is your minuend and this is your subtrahend, right? According to the rules, first find the 9's complement for the subtrahend. How do you do that? 623.85 99999 which is equivalent to 9 minus 5 is 4, 9 minus 8 is 1, 9 minus 3 is 6, 9 minus 2 is 7, 9 minus 6 is 3 again. Okay, now for this one 376.14 and 336.25 we will be doing the normal BCD addition. For 376 places not sufficient here, so I'm just writing it down. So 376, how do you represent those all? You do like 0, 0, 1, 1. And for 7 it is 0, 1, 1, 1, 0, 1, 1, 0 dot. For 1, 0, 0, 0, 1. And for 4 you'll be doing it as 0, 1, 0, 0. And then for 336 what we will be doing? 0, 0, 1, 1 and 0, 1, 1, 0. Oops, I'm sorry, 0 and this is a 1. And for 6 it is 0, 1, 1, 0 dot 0, 0, 1, 0. And for 5 it is 0, 1, 0, 1. Okay, never mess up with the zeros and ones or else your entire answer will be wrong. So okay, now how do we do the normal BCD addition to this? So 0 plus 1 is a 1, 0 plus 0, 0, 1 plus 1 is a 0 with a carry 1. So this is a 1 and this is 1, 1, 0, 0 dot 0, 1 plus 1 is a 0 with the carry 1. 1 plus 1 plus 1 is a 1 with the carry 1 and this is a 1. So 1 plus 1 is a 0 with the carry 1. 1 plus 1 plus 1 is a 1 with the carry 1. 1 plus 1 is a 0 with the carry 1 and this is a 1. And for this one 1 plus 1 is a 0 with the carry 1. 1 plus 1 plus 1 is a 1 with the carry 1. So this is 1 and this is 0. Okay, now let's check which of these are a valid BCD. 0, 1, 1, 0 is a 6, so it's a valid one. 1, 0, 1, 0 is not valid. 1, 1, 0, 0 is not a valid one. 0, 0, 1, 1 is a valid one. 1, 0, 0, 1 is also a valid one. Now, for the invalid BCD, we will be adding 6 to this one. Don't confuse this to be a multiplying symbol. I'm just crossing out which one of them are not a valid BCD. So 0, 1, 1 and 0. So how do we do? 0 plus 0 is a 0, 0 plus 1 is a 1, 1 plus 1 is a 0 with the carry 1 and 1 plus 1 is also 0 with the carry 1. And now here 0 plus 0 is a 0, 1 plus 1 is a 0 with the carry 1, 1 plus 1 is a 0 with the carry 1, here also 0 with the carry 1. Okay, now after getting your carries, what we will be doing? We will be shifting the carry to the next bits. So this one will be added to this one, and this one here, these bits are 0 0. I'll just write down all these bits again. 1 0 0 1. Okay, now this one will be getting added to this one, and this one will be adding to this one. So here goes a 0 0 1 and 0 1 1 1, and this is 0 0 1 0 dot 0 0 1 1 and 1 0 0 1. Okay, now all these are valid ones, but here we are not getting any end around carry. See, according to the rules, if end around carry is generated, we are adding it to the result. Now, if it is not generated, what we will be saying it? The answer is negative, and again we have to find the 9's complement for that one. Now, as the end around carry is not generated, we say that the answer is negative, and we need to find the 9's complement. Okay, what is this one actually? This is a 7, this is a 1, this is a 2, and this is a 3, and this is a 9, right? So it is 7 1 2 dot 3 9. Now, how to find the 9's complement for this one? I know you guys are very well aware of this one. And 7 1 2 dot 3 9. It is something like 9 minus 9 is 0. 9 minus 3 is 6 dot 9 minus 2 is 7. 9 minus 1 is 8. 9 minus 7 is 2. So your answer is negative of 287.6. So it is finally negative of 287.6. So this is your final answer. Now let's check on how to do BCD subtraction using 10's complement. Well, BCD subtraction using 10's complement is almost similar to using the 9's complement. Only few points to just alter apart from those rules are, first we'll be taking 10's complement for subtrahend, and then if end around carry is generated here, we'll discard the carry. According to the 9's complement, what are the changes we have seen here? The only changes are here 9's complement, and here it's a 10's complement. And here, if end around carry is generated, we add it to the result. If end around carry is generated, we discard the carry. Rest all are so similar. Okay, now let's get into the examples for this one. Consider 10.2 minus 2.1. Okay, at first, this is your minuend. Never mess up with these. And this is your subtrahend. Now, one more thing to consider here is that here 1 0 are of 2 digits and 2 is only of single digit. Whenever you want to do subtraction, always make sure that both of them are of equal number of digits. So what we will be doing for 2.1, we will be writing it as 02.1. So this is also of 2 digits and 10 is also of 2 digits. Okay. Now, what do we do the first? We need to find the 10's complement for the subtrahend. Okay, how do we find the 10's complement? By first finding the 9's complement and then adding 1 to it. So 9 minus 1 is 8, 9 minus 2 is 7 and 9. So adding 1 to this one, we get 97.9. Okay, now for the 97.9 and 10.2, we will be finding the equivalent BCD values, which is 841, okay, 1001, and for 7 it is 0111 dot 1001, and for 10 for 1 it is 0001 and 0000 dot 001 and 0. Now do your regular BCD addition. 1101 dot 1110 01 1 0 and a 1. Now check which of these are of valid BCD numbers. This is not a valid one. Well, this is a valid one, and this is also not a valid one. Now what we will be doing, we will be adding 6 to these two. 0 1 1 0. So 1 plus 1 is a 0 with the carry 1. Again a 0 with the carry 1. 0 with the carry 1. This remains the same, 0 1 1 1. And now for this one, 0 plus 0 is a 0. 1 plus 1 is a 0 with the carry 1. This is a 0 with the carry 1, and this is also a 0 with the carry 1. Now here after doing this one, we will be shifting the carry to the next bits. Now we have a carry here, so plus 1 to this one. You will be getting as 0 with the carry 1, 0 with the carry 1, 0 with the carry 1, which is 1. Okay. Now this is 0 0 0 1 and this one. Now what we'll be doing again, now check. If in around carry is generated, we just discard the carry. So here we got an in around carry. So we are just discarding this one. So here it will be 0 0 0 and 0. So what is your final answer? 0 8.1, which is equivalent to 8.1. So finally you got your answer. I really want you to try solving 26.25 minus 38.26 using 10's complement. All the rules are so similar and so easy. Just try solving this one, then you will have a clear idea about how to do BCD subtraction using 10's complement. I hope you like this session. In this next video, we will be covering how to write different code formats. Till then, stay tuned to Edumoon. Thank you.